What do we know about static? Thomas?
It's a source of energy.
Source of energy. Okay, build on that. Denzel.
When you rub like fabric against something, then it causes a bit of electric charge.
You can cling things together kind of with it, or it can push things away, or like try to like if you rub a balloon on your head and then you like pull it up, your hair kind of goes up with it.
So it's like a magnetic force with energy.
Okay, I'm gonna challenge you, okay? I wanna take magnetic out of it because static isn't necessarily magnetic, but the idea of it sticking makes you think along the lines of magnetic, right? What is static? A type of
Electricity.
electricity, right? So we're gonna do an activity today. You get to actually work with the static and the charging of the plexiglass and everything. But I'm gonna show you what that looks like. So quickly, quietly, meet me at the back table. And we're gonna be experiencing what static looks like, how it reacts. All right, so we've got the same setup here as you have at your desk station. What you didn't see was those little tinfoil balls are actually styrofoam balls that we took and wrapped in tinfoil, okay? And remind me, are we as humans, are we conductors or insulators? Raise your hand if you say we're a conductor. So let me ask you this, how many of you have carpet either at home or at a family member's house and you have run around dragging your feet in socks and you go up and you touch something, either metal or a sibling or parent, and they're real thrilled about it, right? You are conducting that static electricity, right? Okay, you've got tinfoil that's taped to your desks, all right? That's standing on wood blocks. You also have a wool cloth here that we're going to use to charge up this plexiglass. It's actually not glass. What does it sound like? Plastic, right? So you're gonna take the wool cloth and just wipe over the surface. I am charging up the plexiglass, okay? So I've done both sides. And I'm gonna take a ball and, oh, my static is not strong. I might need a hand over here. So is he doing a lot or a little? Is he actually touching the ball though?
No.
No. Did he do a lot of charging it or a little?
A lot.
Okay, so what do you think will work best for your experiment? Evan? Doing a lot. All right, off you go. There you go. Charge it up, because remember, you're charging yourself, as silly as that sounds. You're on top.
So I'm assuming that it would work.
Just do it.
We should try it. Oh, that's so cool.
One hand at a time, Dimitri.
This is awesome.
Using your table knife.
That's the blood circulation in your face. That's awesome.
Okay, try from under the...
Because static is actually a type of electricity. That's why I can't control them. Pull all of them out because we're going to do one ball on. So in this activity, we had multiple different conductors going, right? We had the tinfoil, What else did we have?
The tinfoil balls.
The tinfoil balls. What else did we have? Shelby,
Plexiglass.
do you think the plexiglass is a conductor? It didn't really stop the flow, so could we say in theory that the plexiglass is also a conductor?
Yes.
Maybe. What else? Brady?
Us.
Us, right? So static is a type of electricity. So what you were seeing was the electricity from us, right, into the next conductor, right, which was the tinfoil ball. And then that electricity was trying to get to another conductor, which is maybe the plexiglass or the tinfoil on the desk, right? So what you're seeing is the electricity flowing around, static electricity.